Okay, so welcome back. So now what we're going to do is we're going to do an example of estimating an integral that can't be done directly. Okay, so this integral here, we cannot integrate this. Okay, so this is what we call, we can only integrate things that have elementary functions. Okay, so things like this, we cannot integrate because they're not elementary. So there's no antiderivative to this function. So there's no way to do this. So we're going to have to basically approximate it using numerical integration. So now, in this case, we want to approximate this, but the question is what n, so how many subintervals do we need in order to guarantee that the estimate is going to be accurate to within 0.01 if we use the midpoint rule. So we're going to use the midpoint rule, but if we're going to use the midpoint rule, we want to be accurate within 0.01. Okay? So this is our error. This is the maximum error that we want. And we need to figure out how many subintervals will guarantee that we will be no bigger than 0.01 in error. Okay, so first of all, we need to find, so first of all, this is continuous over the interval 0 to 1. And we need to find the second derivative. Okay, so let's do the first derivative. So f prime of x, again, it's a chain rule, so we're going to do the chain rule. So it's going to be e to the x squared times the derivative of the inside function, which is 2x, which gives us 2x e to the x squared. Okay. Now, we want to get the second derivative. That's the one we need. But now we're going to do the product rule. So it's going to be the derivative of the first. So I'm going to take the 2 out. So it's going to be the derivative of the first, which is just 1, times the second, e to the x squared, plus the first times the derivative of the second, which is just 2x. Okay? So again, just to recap, we did the derivative of the first, which is x. Got it? Excuse me. The derivative of the first, which is 1, times the second, which is e to the 2x, so that gave us this one, plus the first times the derivative of the second, which is going to be e to the x squared times 2x. So we get 2x squared times e to the x squared, which gives us 2. Oh, actually, we could factor out e to the x squared. So that's going to give us 2 e to the x squared times 1 plus x squared. Okay? So that's our second derivative. Okay, so now, we want the absolute value of this thing, right? So if we take the absolute value of this, right? So, by the way, this is always positive because e to the x squared is always positive. This is always positive. So this thing's always positive. Okay? So what's the maximum that this thing will be? Well, we're going from 0 to 1, right? So x is going from 0 to 1. So the maximum this thing will ever be is at 1. Right? Oh, hold on. I forgot a 2. Missed it. 2. Yeah, 2x squared. Okay? So the maximum this is going to be when x is equal to 1. So when x is equal to 1, this thing's going to be less than or equal to what? So this is 1. If this is 1, this is going to be e. Right? So it would be 2e times 3. So this will be less than or equal to 6e. So there's our m. Right? So this is our m. Okay, so now we know that the error, because we're using the midpoint rule, the maximum error, right? The error has to be less than or equal to m times b minus a cubed divided by what? It's going to be divided by 12n squared. So if we plug this in, this is going to be equal to what? 6e. Well, b minus a, that's going to be what? It's 1 minus 0 cubed over 12n squared, right? Which is equal to, well, this is just going to be 1 cubed, which is 1. So this is going to be equal to 6e over 12n squared, which basically just reduces to e over 2n squared, right? Oh, wait a minute. I'm thinking trapezoidal. Right, because midpoint rule is more accurate. So this needs to be 24. Sorry about that. So this is 24. And so this is going to be 4. Okay, so yeah, just remember, we're using the midpoint rule, so this has to be 24 down here. Okay, so now, what does that mean? Well, this then, what do we want? What's the maximum error we want? 0.01. So we want this to be no bigger than 0.01. So we want e over 4n squared to be less than or equal to 0.01. And now we solve for n. Okay, so basically this means that n needs to be less than or equal to, right? So if we solve for n, so flip these, right? So if we flip these, we're going to get the square root of that, right? Which is approximately equal to what? What do we get? We get 8.24. Okay, so what is the value of n then that we need to use? It's going to be 9, right? So n has to be 9. We can't have a fractional n. And we don't want to round down, because if we round down, guess what? That means our error could be higher than 0.01. So we always round down in these cases. Or excuse me, round up. We always round up, because that guarantees that our error will be smaller. So we always round up. If there's unless it comes out perfectly as a round number, which hardly ever happens, we always want to round up to the next higher integer. Okay, so n, then we need to have at least 9 subintervals. That's the minimum number of subintervals we need. in order to guarantee that our estimate is accurate to within 0.01. Okay? Now, so what does this mean? Okay, so let's write this out. Okay? So, now that we have our answer, let's write this out as far as what this means. Okay, so what we're saying is the difference between the error, again, go back to our absolute error, right? So this is our absolute error, 0.01. So what does that mean? So if we write this, we're take the actual value, right? The true value, the absolute value, so we're saying the true value come on. So the absolute value of the difference between the true value of the integral and our estimated value of the integral, which in this case is m what? In this case it's going to be m sub n, right, of the midpoint rule, right, is less than 0.01. Well, do we want to use less than? Yeah, in this case, less than 0.01. Okay, if n equals 9. Right? So we know that this distance, this difference here, our absolute error is less than 0.01 if n is equal to 9. That's what we get down here. And that's it. Do I have one for you? Yes, I do. I might have given you this one already, but that's okay. So let's do this. Find the upper bound using M4. So find M4 if you haven't. Oh, let me do this. So let's do the integral from 0 to 1 of x squared dx. Let's take that one. Now that's an easy one. You can integrate that. But what I want to do is find the upper bound, right? So I want you to find the upper bound. I want you to use M4 and find the upper bound of using M4 to estimate this integral. Okay? And then what I also want you to do is, so that'll be 1, right? 1. And then 2, I want you to find n such that the maximum error using the midpoint rule is going to be less than or to within 0.001. Okay, so 2 questions there. So this one here, part 1 is, okay, find M4, okay, using the midpoint rule, M4 with 4 subintervals. I want you to find the maximum bound, the maximum error bound for estimating this integral. That's 1. 2, then, using the midpoint rule, I want you to find the number of subintervals. I want you to find n such that the error bound will be within 0.001. That's it. Have a great day.